In this video lecture, let us study or, or how to select a fin, what are the different shapes in the fins, and how the once we are having a fin, how to evaluate the fin performances. So far we have studied what are the different heat transfer effect that is taking place with the long fin, short fin, and insulated fin. Let us understand some of the dimensionless number and their physical significance. The first number is Reynolds number. Reynolds number, and it is generally written as a RE, that is given as a UT by or rho V. Instead of U, we can write this as a mu, or this is a PL by nu. So this is nothing but inertia force by viscous force. This is nothing but inertia force by viscous force. And Reynolds number signifies the relative predominance, right? It gives us the relative predominance of inertia, right? Of inertia. So to the viscous force occurring in the flow system. That means higher the Reynolds number, higher the Reynolds number, greater greater will be the relative contribution to inertia effect. It will be greater effect to the inertia effect. Or if I, in other words, I can tell smaller the value of the Reynolds number, greater will be the relative magnitude of a viscous stresses. So if the smaller value or the smaller value of a Reynolds number will be, I will be having relative magnitude relative magnitude of viscous stresses. So it will be having a viscous stresses. So Reynolds number is taken as an important criteria of kinematic and dynamic similarities in the forced convection heat transfer. So one more important thing, it determines whether the flow is laminar or turbulent, laminar or turbulent. So if it is for the external flow, we consider 5 into 10 to the 5. If it is not given, generally this is a range for the conversion, and for the internal flow, it is a 2300 has been considered as the uh, laminar flow, and if it is exceeding these values, this first one is for the external flow, this is external flow, and this is for the internal flow. The next number that under study is a Prandtl number, right? It is a Prandtl number, and the Prandtl number is the ratio of kinematic viscosity to the thermal diffusivity. So, and it is a see PR is given as a mu Cp by K. It is nothing but molecular diffusivity of momentum, diffusivity of momentum, momentum to the molecular diffusivity of heat. So, molecular diffusivity of heat. The kinematic viscosity indicates the impulse transport through molecular friction, whereas thermal diffusivity indicates the heat energy transfer by conduction process. So the Prandtl number will be helping us to measure a relative, it will help us in a relative effectiveness, relative effectiveness of momentum of a momentum and energy transport, right? These are the few things that we come from a Prandtl number. Prandtl number is a connecting link between velocity field and a temperature field. So this is also a very important point to be noted. It is a connecting link. It is a connecting link between velocity and field and temperature field temperature field. So that is a uh, one more important significance. So uh, here for the gases, the Prandtl number is near to 1. That is the transfer momentum and the energy by the diffusion process is comparable. For oil, this is for the for gases. So Prandtl number is greater than 1 for oil. This is a so here momentum diffusion much greater than the energy diffusion. For the for liquid, it is a Prandtl number is smaller than 1. So here the moment of diffusion is a much lesser than energy diffusion. So by looking into the Prandtl number, one can identify whether the fluid is a liquid, whether the fluid is oil, or whether the fluid is a gases. The next number to be studied is the Nusselt number. So third number is a Nusselt number. It is a given by the notation Nu. It is a ratio of heat flow rate by convection process under a unit temperature gradient to the heat flow rate by conduction process under a unit temperature gradient through a stationary thickness of L meter. Thus, Nu is given as a Q convection by Q conduction, and or it can be written as a H K by L, or it can be written as HL by K. So it is a ratio of the heat transfer rate Q to the rate at which heat would be conducted within the fluid under the temperature gradient. So that is a can be written as a delta T by L. Thus Nusselt number is Q by delta theta into K divided by L, or it can be written as Q by delta theta into L by K, or is nothing but HL by K. It is a ratio of characteristic length L to the thickness delta X of a stationary fluid layer conducting the heat at the same rate under the same temperature difference as in the case of convection process. Thus, Q we can also write here as a Q is equal to K into delta T by delta X, right? Where delta X is equal to K by H. Therefore, this is a H delta T. So, therefore, Nusselt number is L by delta X, that is equal to L by K divided by H, or HL by K. The Nusselt number in a convenient measure of a convective heat transfer coefficient for a given value of the Nusselt number, the convective heat transfer coefficient is directly proportional to the thermal conductivity of the fluid and inversely proportional to the significant length parameter. So, the Nusselt number we can, if it is 1, right, there is no convection, that is for pure conduction of heat transfer to take place, and n Nusselt number is greater than 1 implies enhanced heat transfer by convection. The One more number which we are supposed to study is the Prashanth number. So the fourth number is a very important number, is a Prashanth number. So what is Prashanth number? And it is given as a GR. Prashanth number is related with the natural convection heat transfer. It is defined as the ratio of the product of inertia force and buoyancy force. So the Prashanth number is given as inertia force into buoyancy force divided by viscous force square of the viscous force, right, viscous force square. So it is a in short we can write this as a rho square b g delta t into L cube by mu square. So Grashof number has a role in the free convection. So similar to that is played by the Reynolds number in the forced convection. So free convection is usually suppressed at a sufficiently small Grashof number. Begins at some critical value of a Grashof number depending upon the arrangement and then becomes more and more effective with the increasing Grashof number. So other numbers which are can be studied under dimensional analysis are, in short, if you have to tell, it is a, we can tell these are a fifth number is Stanton number. Stanton number is defined as the ratio of the Nusselt number and the product of Reynolds number and Prandtl number. It is worth noting that Stanton number can be used only correlating force. It is used for the correlating forced convection data. Forced convection data. Forced convection data. It can be used. The numerator represents heat flux to the fluid and denominator represents the heat transfer capacity of the fluid flow. So the ST or the Stanton number is given as a H is convective heat transfer coefficient to the rho V into Cp value. Then the next number we can tell it is a Prashanth number, right? It is given by PE. It is a ratio of the mass of the heat flow rate by the convection to the flow rate by conduction under a unit temperature gradient and through the thickness L. The seventh number or the one more number we can give as a G, Reynolds number. It is related only for the heat flow to the fluid flowing through the circular pipe. It is defined as a ratio of the heat capacity of fluid through the pipe per unit length of the pipe to the conducting of the pipe. So then the eighth number we can define as a skimmed number. And what is skimmed number? Skimmed number is having kinematic viscosity to diffusion coefficient as a ratio of a diffusion coefficient, right? So it forms a relationship between velocity and the concentration of profile, and thus this profile become identical when skimmed number is a 1. Then ninth one we can tell it is a Sherwood number. Sherwood number is used similar to the Nusselt number in the convective heat transfer. In force convection, mass transfer, the correlation would be of the form that the Sherwood number is a function of a Reynolds number and SSC, that is skimmed number. Then the last number is a Lewis number. Lewis number is generally given as a alpha by D. It is thermal diffusivity to the mass diffusivity. It forms a relation between temperature and concentration profile, and their profile becomes identical when LC is equal to 1.